I'm Fahim Chandurwala. I work for Wolfram. And this talk is going to be about data feeds in Wolfram Finance Platform. And we're going to talk about Bloomberg link and Reuters link together and how the integration of it works in Mathematica and the usefulness of it. And Bloomberg, Reuters. Okay, so what we'll go over here is configuration, because you're going to connect to the outside world here. Reuters and Bloomberg, they have own preferences to connect to their servers, so we'll go over that. Then we'll go over the syntax of how you're going to make those requests in Mathematica using Wolfram language. We'll talk about the real-time feeds, the output time series charting, because these are very useful features of the Wolfram language, and then the report generation, and how all these things come together in the finance platform. So over here, there is a small configuration. You just put it once. You put in your host. You put in your request timeouts. And then it stays on the disk. That means once you have configured it, it's done. You never have to change your sessions, or you restart Mathematica, it will still work. OK. So these are some of the queries that you'll make to the Reuters servers. And in the syntax, you'll see that when you're connecting to the Bloomberg, you're using specific names: IBM, UN Equity, which is NYSE, and IBM.N when you're doing Reuters. And PX_last is the closing price of that instrument. So let's see. So you get, we will talk about the output a bit later, and then you can do from and all the connection is also automatic. So when you say it's Bloomberg, we'll connect to Bloomberg automatically, and you don't have to give it all the time. Only in rare occasions will people be using both sources. So in that case, you'll just be able to get rid of that option and keep going on. And here we'll talk a little bit about the output. This is the raw tick data from on October 17th, 10:30 to 10:31. I can make that query again. It will take a little bit of time. Oops. There you go. Sometimes it times out. OK. What this table is showing is all the events that happened between that minute. How many bids were there, how many people put in what value they were asking for this equity, and at what price did the equity got traded. And the size is the volume. So 500 shares got traded at $181.9. OK, so this is absolute raw data in dataset format. And this is another query that you can make to Bloomberg. What it will give you is the bar data. So from 10:30 to 10:31, in that minute, at the beginning of that minute was the price, so that's the open. In that minute was the highest price for the equity, low, close, and the volume that got traded, and the value. It's volume times the average value. Now here's things get cute. you have to make 2 queries to get the average data, that is the bar data, open, high, low, close, or you can make another query which is just raw data and use the built-in functionality of the language, the data set language, to make the market data call, the average data. And this can be done locally. You don't have to make another query to Bloomberg to get that data. And it's very simple. I took the raw data that was in the previous slide right here, and I grouped them: bid, ask, and trade. Now, because we asked for the trade price here from Bloomberg, we're going to compare the results that we get using data set queries on raw data and directly from Bloomberg. So as you can see that trade total, and I do a total, which is a built-in language function, and do a size on it, and it's 860, 860. And you can see that's the 860. So very compact things. And you can, the reason I'm emphasizing this is because Bloomberg and Reuters, they have a quota on the queries. They have many fields, and you don't want to make so many calls. You might be interested in different fields from Bloomberg, and you don't want to run out of your quota. And there is the overhead of asking and the process of making the connection overhead of that happens on the wire. This happens locally. I'll talk about the real time a little later. But here's another thing, historical data, which is very useful when you're trying to do backtesting and your procedures. And the language is immensely powerful in using and making queries on this. And here I'll do, this is year-to-date data, and the syntax is rather compact, and it's very nice that you give instruments, which is right over here, and properties that you wish to have, open, loss price, high, low, and the volume. And we want from the beginning of the year to, I could have done today, but markets have not closed yet, so I'll do yesterday. And it's rather readable, and data object, it will just understand it that, okay, you're trying from the beginning of the year. And let me run this query in real time. Oh, I should explain what the split is. Apple split this year, so we'll have to make adjustment for those. And otherwise, it will give us $500 or whatever the price was in the beginning or until May when it did split. So there we have the data. And you can make similar queries with Reuters, but the instruments and the fields change a little bit. But the concept is exactly the same. Okay. Now, every time you get a historical data, few things you would like to do is get the time series out of it, right? And with data set and the query language that goes along with it makes it very, very easy. And all here I'm doing is, look, I want the Microsoft data, and I want the date and the closing price, so I can get the histogram or the time series for it. I'll just delete this. It did change? OK. And then other things that you might be interested in the trading charts. Notice that we are not making any new queries here. Everything happens locally. And I'm selecting the Microsoft instrument, and I'm giving date, open, high, low, close, which are actually the names of the columns that we received in the data set above. Open, high, low, close. And that's how I'm constructing this trading chart in a very quick manner. Then okay, so another thing you could do is just group things by instruments and then by date and get the time series of it. And that's the query. That's it. You're done. And you get all the time series. And OK. So just to show you that this is actually, you can interpolate January 1st. Now, January 4th was the weekend. Yes, January 1st was the weekend. And it will actually compute and interpolate what the price was on the weekends if it is computable. Then we have scoring functions. Now, because we have made the data set flat, so there is no introduction of hierarchy, it is very easy to make simple queries, interesting queries that, OK, on what day was a particular instrument at its best? So Apple closed, and this is the query that you can make. I'm grouping it by instruments and then getting the maximum, scoring it by the closing price. And I get the date. And here is the, because I want to do it on a, I want the date over here is that. If I wanted other data, I can just do this. And you get the volume if you were interested in that. And we can apply functions to it also directly, like group by instrument. I want the mean, standard deviation, and change. And there you have it. So Apple changed $1.73 and so on and so forth. And these are the mean and closing prices. And you have created a new data set, and you can make different queries using that. This was very, very interesting. Like, I wanted to compute the 30-day moving average. Bloomberg computes it for you. You can fetch it directly. And I tried to do the same thing. And the simplest thing that occurred was, initially I tried date plus, today minus 30. And you can create this. Okay. OK, so it gives you, when you do just 30, date plus today minus 30, it gives you Tuesday 23rd. But those are not 30 days, business days, right? And so when you're computing different answers, one is business day, one is the other thing. And you can, 30 days, business days ago, you get this data. And then you compare it directly from the Bloomberg data. You can make this direct query, use your quota again, and it's an agreement. Apple was 103 moving average for 30 days, And we have the same values for all of them. And you can do some more fun queries a little bit. So I wanted to figure out what is a good day to trade a particular equity. And because our data set allows it, and our language allows grouping by day name, so here I'm concerned with Thursday, Friday, Saturday, Sunday, business days, okay. And it will give me, yes, grouped. So after that, you can compute, OK, I want the mean price standard deviation for it. And I can do that also. Excellent. OK, so something is not showing properly, but that's formatting. But I can get, OK, these are the stats on Thursday for all the equities. And you get the mean prices. Then, OK, fine. Looking at it doesn't look very nice, so we can do a list plot. And that's it. You just do a stats all Apple use. You're given the keys and the column you want, and you do a list line plot on it. And it seems like Thursday, Friday, Monday. Monday is a good day. Tuesday, not so good. And Wednesday, better. OK. So
keep going.
OK. So
Corrections have to be run on special hardware, so that's why it has to be
OK. So Thursday, Friday, Monday, and Wednesdays are a good day to trade for Apple. Now, you can do this query. Now, this is a smaller data set. OK, here's the interesting thing. So I figured, fine, I'm getting all this average for the whole year up to today. But can I predict that is Monday, Tuesday, Mondays, and Wednesday a good day to trade for Apple or sell them? So I created a smaller data set up to only February. So that's what it means. So I'm going to select from the data that I got up to the date of February 1st. And that's that query. And I can do exactly the same thing. And it seems, even though the plots are a bit skewed because you have the small amount of data, Monday is still the good date to sell your Apple shares if you want to, that is. OK. So that's a bit of fun with that. And then the report generation. We have this capability of making your own templates, and it will generate a report for yourself. And this is the demo of that. So you can just say, I've already created the template, and I don't think I may have time for that. So author, stocks, name, and Microsoft equity. So I can initialize that. And I'll create the document, and hopefully, there you go. And you have this document created for you, and within a couple of lines, you can actually export it to the cloud. This finished, so which is nice. Hopefully my session has not expired. There you have it. It's in the cloud in a web browser, and you can take a look at it. Oh, and it gives you the time also. That was nice. What time is it? Yeah, exactly. Good. And all right, so I'm going to go quickly to the real-time data. And over here, you have made the query, or this is the things you want in real time. And if the markets are still running, you might be able to see some change. Oh, they changed. OK. So it's real time for. And you can do the same with Reuters. So hopefully, I should have put in a volume over here.
It's changing.
Oh, OK. And so that was pretty much the whole integration with Wolfram language and outside sources for financial purposes. And so we have a powerful query, very compact and user-friendly syntax. We get time series and charting capabilities right out of the box, and integration with the cloud, everything in one go. And I don't think I ever wrote anything long or any clever thing, so which makes it very, very nice. And it prevents you from using your subscriptions too much within the language. And I think that's a very good thing. And all of this does come with Wolfram Finance Platform. Few things may change. It's still under discussion, but you can check out the website a little bit. If I can start my Firefox. Aha. So this is a product in existence. We already have Bloomberg link out there. We are introducing Reuters link with it. And that's it. And I think I'm out of time.